Everyone, in today's video I will be solving a problem based on inference line diagram. So this is the question here. It says that a simply supported beam of span 8 meter is loaded as shown. This is the question. Okay, so here this is a simply supported beam which is of 8 meter length. The whole length is of 8 meter, and here for this simply supported beam we have to find the shear force, bending moment, this shear force and bending moment at section 4 meter from the left end. That means we have to find the shear force and the bending moment at section 4. So this is the 4 meter distance from left. This is left side and this is the right side. So we have to find the shear force and bending moment from this side. This is 4 meter, and we have to draw the ILD for support reaction, shear force and bending moment. Okay, now next is to draw a inference line for RA and RB, and this has been explained in my previous video, so you can go and check it out in my previous video. So now we'll draw IL for RA for a simply supported beam. Okay, for a simply supported beam the IL will be different, and for a cantilever it will be different. Okay, so now for a simply supported beam the IL diagram for RA will be like this, and here you have to write IL for RA. Okay, so now see, we have to draw the imaginary line here. Okay, here one load is acting at this point, again one load is there, and here also one load is there. Okay, and our this point is RA, and here it's RB. Okay, and the whole length is 8 meter. Now we have to draw IL for RA. So the diagram was like this for RA. IL for RB, right? So this is the diagram for IL for RB. Okay, so again we have to draw this line like this where the point load is acting. Okay, so this is the line and this is also the line. So this one was RA and this is RB, and the total length of this beam is 8 meter. Okay, this one is IL. IL is nothing but the inference line for RA and RB. Now here this point and this point, we have to find the value for those points where the load is acting. Okay, let's assume it as x1, this one is x2, and this one is x3. Okay, so now what we have to do, we have to find those values by using the similar triangle method. Okay, so as we all know what is the similar triangle method, right? So now for RA will find those values. Okay, when we are finding for RA we have to see this diagram, and when we are finding for RB we have to look into this diagram. Okay, so first we'll solve for this. Okay, so here the x1 for RA, the x1 how we'll find? From the similar triangle, from the similar triangle method, right? So similar triangle method is what? Suppose, okay, I'll give the example here. Suppose it's a triangle, and here also, and it's 1, and we have to find for this point, and suppose the value of this one is 4. So from the similar triangle method, what we have to do, this big triangle, this is a whole triangle, right? Whole triangle is equal to this small triangle. So here this big triangle is height is 1 by it's 1 by 4, right? So it's 1 by the length 4 is equal to this small triangle, and this value is not known to us, so question mark will be there, divided by from here to here length is supposed 2 meter, so it will be 2. So from this we can find, right? We'll keep the value here and it will be 2 by 4. So whichever the value will come here, whatever, so that will be the value for this. So likewise we have to find for this array. For array we have to find x1, x2 and x3. Okay, so what is there? It's a 1 unit weight. Okay, 1 unit weight. So here also this is the whole triangle, right? Whole triangle is equal to, if we are finding for this point, then we have to assume this triangle. Okay, now we are finding for RA. Okay, I have to draw the diagram here again, I guess. Yes, so it was like this, right? Influence line diagram, and here and here, this one x1, x2 and x3, and this point is 1, and the whole distance is 8 meter. Each distance from this to this is 2 meter, and this point is A and this point is B, right? Now we have to find for this point, then it will be 1 by the whole distance is 8 is equal to this triangle, right? This triangle is x1 divided by from here to here distance is 6. Now from here we will get the value of x1 is equal to 0.75. so here the value of x1 is 0.75. likewise we have to find for this point also. Now that will be 1 by 8 will be same, is equal to x1 divided by from here to here distance is 4, so 4 it was x2. So from here we can get the value of x2, that is 0.5. again we have to find for x3, and 1 by 8 is equal to x3 divided by from here to here distance is 2, so we'll get the x3 value around 0.25. likewise we have to find the value for x1, x2, x3 for RV also. Okay, so here RV diagram was like this, right? This was RV diagram, so it's a, I'll write here IL for RB. Here also same, we have to find the value of x1, x2, x3, right? x1, x2 and x3. so here this one is A and this one is B, so the value will be like, see, the steps will be same. We have to find those value with same formula only. Okay, like RA. So here RV value will be, I directly write the answer. Okay, x1 value will be 0.25, x2 value will be 0.5 and x3 value will be 0.75. okay, so I'll write down here the value of x1 was 0.75, this one, and x2 value is 0.5 and x3 value is 0.25. now for RV the x1 value is 0.25, x2 is 0.5 and x3 is 0.75. so here see, it's just opposite of RA diagram. Okay, now we have to find the reaction. Okay, and to find the reaction, always remember, in case of the ILD, that is influence line diagram, we have to multiply the load into the corresponding ordinates. Okay, so corresponding ordinates. Okay, these things is very important to remember. Okay, now here see, to find the RA, RA is equal to load into the corresponding. In the beam, I have to redraw the diagram, I guess. Okay, so the draw was like this. Here is RA and this one is RB, and here 3 load is acting, and the load was of 20, 60 and 20, right? And now the RA diagram was like this, right? So we have all the values for, sorry, this one was for AB, right? So RA, IL for RA diagram is like this, and IL diagram for RB is like this. So here, here and here. Okay, we have all the values with us, x1, x2 and x3, and it was 0. What was the value? 0.75. okay, 0.75, 0.5 and 0.25, and opposite of this one is here in case of IL for RB, 0.25, 0.5 and 0.75. This point is A and this point is B. Okay, now to find the reaction means we have to find RA and RB value here. So here, to find the reaction in case of the influence line diagram, what we have to do, we have to multiply this load with this corresponding ordinates. Okay, so now 20 into 0.75, right? 0.75. so plus this 60 into this corresponding ordinate is 0.5 plus 20 into 0.25. so after solving this, we'll get the value of RA is 50 kilonewton. Okay, now again we have to find for the RB value. See, whenever we are finding for the RA value, we have to look into this IL diagram for RA, and if we are finding for RB value, then we have to look into this diagram, that is IL for RB. Okay, same thing, we have to multiply the load with the corresponding ordinates. Now for RB it will be 20, this load is 20 and the corresponding ordinate is 0.25, right? Plus 60 into 0.5 plus 20 into 0.75. so the value will come around 50 kilonewton, same like RA. So here we have a value of RA and RB. So here this is RA and this one is RB. Okay, now we have to calculate for shear force. Now calculation for shear force. I'll write the shear force in short. Okay, so now next is to find the shear force. So here, for a simply supported beam, the influence line diagram, see, now in the question what it says is we have to find the shear force and bending moment from left side, and the distance is 4 meters, right? So suppose it was, okay, we have to find the shear force and bending moment for this point, that is 4 meters. So now the shear force diagram was like this in case of the simply supported beam. This one I have already explained you in my previous video, so you can go and check it out. So now this is the, just write IL for shear force at D. Okay, this is the D point, suppose A, B. Now here what we have to do, RA value, we have a RA value as well as RB value, right? That is 50, and this one was also 50. Again we have to draw this line, we have to continue this line, right? So it's like shifted here to somewhere where, and this load is somewhere here. Okay, now again from a similar triangle we have to find this value, x value and this value. Okay, so let's assume it as x1 and x2. Now same way like before, we have to find those values with what? Similar triangle, and we already know this value, that is 0.05 and 0.5. okay, from this one we have already got the value, right? That was this one. X2 value is 0.5 and RB for x2 value is also 0.5. In case of the shear force, one will go negative and one will go positive. Now write like this again, from a similar triangle, we can easily find the value of this, right? This is a big triangle, that means it's 0.5 by the length is from here to here is 4 meter, right? By 4 is equal to, this is the unknown, that is x1, divided by from here to here it's 2 meter, so 2. So we'll get the value of x1 is equal to 0.25. I'll write down here, that is 0.25. again we have to find for this value. Okay, let's take g2. okay, so now again it will be same like 0.5 by 4 is equal to x2 by 2. Value will be same for x1 and x2, that is 0.25, just 0.25. okay, now we have to find for the shear force at this D point. Now shear force, okay, shear force is designated by this as F. First we'll find for the left hand side, this side, okay, and we have to find for the right side as well. So now we'll find for the shear force from the left end. So now from the left end, what we have to do here, from the, now here also we have to take the load, multiply the load with the ordinates. So here what was the load? This was the question, right? So the load was 20, so here it will be 20 into the ordinates is 0.25, right? And it's negative, so it will be negative, yeah, okay, so into negative 0.25 plus, again this load is 60, so 60 into, this is negative, but in case of when we are starting from the left, we have to take the positive value here, okay, so we'll take the positive value, that is 0.5 plus, again the load was 20 into the corresponding ordinate is again 0.25. So we can get the value of shear force from the left end, that is 30 kilonewton. Now we'll find for shear force from the right end, shear force from right, okay, so it will be 20 into 0.25 plus 60 into, when we are finding for the right end, then we have to take the negative 0.5, okay, so it will be minus 0.5 plus it will be 20 into 0.25, so we'll get the value of this one is minus 30 kilonewton. Now we have a value for shear force at point D, that is 30 kilonewton, and from the right end it's minus 30 kilonewton. Now next is to calculate the bending moment. So here I'll write calculation for bending moment, okay, this one is for the bending moment. Now again I have to redraw the diagram, and 3 loads was there, okay, the whole length is 8 meter, each distance is 2 meter, 2 meter, 2 meter and 2 meter. This is A and this is B, and the load is 20, 60 and 20, and the bending moment diagram is like this. So we are finding for this point, then the maximum bending will be occur here, okay. So what was the formula here? That is L minus A divided by L into A, right? This is A and this is B, and we have to find for this point and also for this point. Okay, now again from a similar triangle we'll get the value of this one and this one. So I'll solve here from a similar triangle, right, like this. From a similar triangle method we'll get the value of x1. Okay, so x1 will be, big triangle is this one, and again we have to assume this triangle, right? So it will be what was the value here? So we have to calculate this value. Okay, so it was L minus A by L into A. So just find L is the total length, that is 8, minus A is from here to here distance, okay, and that is 4 divided by 8 into A is 4. So we'll be getting the value of maximum bending moment is 2. Okay, now we have a value for this. So now we can easily put in the similar triangle method, that is 2 by the A value is 4, right? 4 is equal to the unknown. The unknown is x1 divided by, from here to here it's 2 meter, right? 2. So from here we'll get the value of x1 is equal to 1. Same like this we have to find for this value, and it will also come as 1. Okay, now we have to find the bending moment for this point, that is D. Again we have to do the thing, load with the corresponding ordinates we have to multiply. Okay, so now write like this: bending moment at D is equal to this is the load and this is the corresponding ordinates. So here it will be 20 into 1 plus the second is 60 into 2, na? 60 into 2 plus again 20 into 1. So we'll get the value of bending moment at D is 160 kilonewton meter. So now we have all the values with us, that is bending moment at D and shear force, this value and this value, and also the reaction. Okay, so this was all about this question. Okay, again I'll explain you in short. In this question what it says, that we have to draw the ILD diagram for support, reaction, shear force and the bending moment. But here the shear force and the bending moment we have to calculate at section 4 meter from the left end. Okay, so this was the diagram, and this both diagram is for the IL diagram, that is influence line diagram for RA, and this one is for the RB, and I have explained you in my previous video how it has been drawn. Okay, so next is to find those values x1, x2 and x3, same like this value from a similar triangle method. So this is the method for finding the x1, x2 and x3 value. Now to find the reaction, what we have to do, we have to multiply the load with the corresponding ordinates. Here in the question, here see, here is the question, right? This was the question and this is the A and B point. So to find the reaction of RA, what we have to do, we have to see the RA diagram, and here to find this one, what we have to do is this load into the same, this ordinates we have to multiply. So here we have done like this. Okay, see, RA is equal to, we have to see this diagram in case of the RA and the lower one for the RB. So now here load into the ordinates, 20, this one is 20 into the ordinates, right, plus 60, this is the load, this is the ordinate, and again 20 into this one was the ordinate. Same like RB value also we have to solve the RB value by continuing this process only. Now next is to calculate for the shear force. Now for the shear force, this is the diagram, and this diagram has also been shown in my previous video, so you can go and check it out how it has been drawn, how it has been calculated and drawn. Okay, now again for the from the similar triangle, again we have to find those values x1 and x2. Okay, so after getting those values, we have to find for the shear force from the left side as well as from the right side. So here also we have to multiply this load and the ordinates. So likewise we got the values, that is 30 and the minus 30 for the shear force at the right side. Now the last step is to calculate for the bending moment. Here this is the diagram for the IL diagram for the bending moment, and in the maximum bending moment this is the formula, and this is the formula only in case of the shear simply supported beam. Okay, that is L minus A divided by L into A, and this formula has also been solved in my previous video. Okay, now this is the formula, and we have to find the value of this maximum bending moment. So just we have to put those values in this formula, then we'll get the value around 2. Okay, so now again from the similar triangle we have to find this value as well as this value from a similar triangle, and after getting the values we have to find for the bending moment at this point as it has been mentioned in the question. So now what we have to do, again the same thing, we have to multiply the load with the corresponding ordinates. So here it has been done. See, here 20 load was acting, right? 20 into the ordinates is 1, plus here 60 into 2, the value of this one is 2, right? Plus 20, here 20 load was acting into the 1, x2 value is 1. So after simplifying this, we will get the bending moment around 160 kilonewton meter. Okay, so this was it for today's. In my next video again I will be solving a problem based on influence line diagram. Okay, thank you.